Hello everyone, it's April 19th. Alright, let's get it started. Before we start, of course, take a look here. Nothing of concern. Alright, let's do this. Combination sum 4. Wow. My neck hurts. Well, I did, before we start, I just want to say I have been wanting to use Streamlit for a very long time. Now, Streamlit is a Python tool to write a data visualization app. It's ridiculously powerful. Well, I shouldn't say ridiculously powerful. There's still room to grow for this, but it's very easy to use, as you can see here. Right, you write this, and then the app just comes out, and you can put all kinds of graph in it, and then it allows you to have simple widgets. Simple widgets to do interactive data visualization. It's very neat, very neat. There are still issues with this, but there are workarounds. And I've been playing with this whole afternoon, trying to do some data visualization for my work, and it was very nice. It was very nice. And of course, that's not the only thing. The problem that Streamlit solved is it allows you to have a simple way to deploy your visualization on a web app. Right? It's basically just write these code and boom, the web app is already configured for you behind the scene. But the real magic, right? The real magic for interaction, that Streamlit provides some level of interaction. Like it has like buttons and select boxes and radios and like all those general ways for handling user input. Right, this is good, and of course, based on user input, you can decide what type of data you want to show, if you want to hide something or not. But the real power comes from here. This thing, Altair. Altair is using Vega at the backend. Altair is just a wrapper for the Vega project. And the Vega project can create some really interesting things. And they have interactive charts as well. And these interactive charts just completely blow my mind. Like this one, right? You can select. I'm not sure if this one is running right now. Yeah, you see, you can select, and then based on the data you select, right? Based on data you select, the left-hand side will change. And you see, like I actually check every single one of them because it's just bonkers, right? It's just bonkers. Look at this. Look at this. I can select, and it will show different. And the code is not that long, right? It's not that long. So I just create something similar to this, and it feel pretty good, And I'm actually going to try to deploy it so that I have a way to see it and share it with other people. Anyway, so this is just something I've been doing, and I think if you are interested in data science and want to share what you have done, you can definitely do Jupyter Notebook. You can share your notebook. There are a lot of online ways and the free ways to run your notebook, so people can see how things are, and all these things can run. Like the Altair can run on Jupyter Notebook, Jupyter Lab, doesn't matter. It works very well. But if you do that, you're also sharing your code, right? So what if you don't want to share your code, right? What if you want to just send it to somebody who don't really care about the code and just want to play with the data visualization part, play with the interactive part? I think a web app is the final way to do so. It's like if you say you can build something, right? And then in this day and age, you say I've built this, I built a game, I built some utility. How do you convey your value? How do you show your value to other people? Web app, right? That's the only thing that's universal right now. It's simple for other people to check, and for people who don't know it, they'll just think you're like doing black magic. All right. And finally, I want to say, we are not doing black magic. Software engineers are not magicians. The real magicians are those RF guys, those radio signal guys. These people are magicians, conjuring things out of thin air. All right, so enough of this. Let's get into this. It's not that long, huh? Given an array of distinct integers, okay, and a target integer, okay, return the number of possible combinations that add up to target. The answer is guaranteed to fit in 32. Ooh, and you'd allow repetition. I think I've done this before. Right? I think I've definitely done this before. All the elements are unique. What if negative not allowed in the array? How does it change the problem? To allow negative numbers. What? Why would there be a problem with negative numbers? Oh, there'll be infinite ways, right? Like if I have -1 plus 1, just -1 plus 1, -1 plus 1, there'll be infinite ways. So what limitation? Each negative number can only be used once. Something like that. All right. I think I've definitely done this before, but like always, I forget. I always forget how I did it. I think what I did was pick one, right? So let's just look at this 1, 2, 3, right? I can pick one, so I need 2, 3 to sum up to 3, right? That's it. But that's using one once, right? You can use one again. So I should pick one and then 1, 2, 3 to give me 3, and then I can pick one again and then 1, 2, 3 to give me 2, and pick one again and then 1, 2, 3 to give me 3. Give me 1, and that's only one can do, right? Okay, actually pick one and then do it again. 1, 2, 3, give me 0, which is 0, cannot do. So I have 1, 1, 1, 1, right? And I have this. And then I can pick 2, all right? I can pick 2, but I cannot pick 2 to give me 1, because that's bonkers. You cannot pick 2 to give you 1. If you pick 2, and then it's not, and pick 3 is not. Okay, that's it. So going back, it's a 1, 1. I have 1, 1, I have 1, 2, 3, give me 2. So I pick 1 already, so I'm going to pick 2. If I pick 2, that's equal, then we're good. So that's that. And pick 3, we cannot pick 3. Go back. So 1, 2, 3, pick 3. So I'm going to pick 3. I'm going to pick 2. Oh, then we have repetitions. Oh, these are considered different? 1, 2, 3, 4, 5, 6, 7. Okay, they are considered different. Now it's even easier. You don't have to consider duplicates. These are duplicates. I think what the version I've done is you cannot have duplicates. Now these are duplicates. This, and this are duplicates. This and this are duplicates. I mean, if it's duplicates, I remember it's slightly. It's actually more difficult if you want to remove duplicates. How do you remove duplicates? Well, you remove duplicates. You remove duplicates by saying every time, like we pick 2, right? If we'll pick 1 and 2, and then we have 1 left, then you cannot pick a value that is smaller than itself, and then you can do. But now it's fine. I think we probably have it. Yeah, I need to do this fast today because it's already 9 o'clock and I am very hungry. I need to eat. I am hungry. I need to eat. So let's just do this fast so we can eat. And I need to feed my cat. So we have about half an hour. Let's see if we can do this in half an hour. All right, so we're gonna do a helper. We're gonna have a res is going to be a this def helper. What's the helper gonna do? Well, the helper is going to do index, right? We'll have the index, and then what? then we need a temp. This is a current. Let's call it current. Let's don't call it temp. Let's call it current. What are you doing? Let's call it list. This one is gonna return none. Not gonna return anything. So what we do is index. So when I pick the first one, all right? When I pick the first one, I'm gonna say if hold on, how should we say? We have we have a target as well. So like current target. All right, that's neat. So when I say, when I pick this one, so if the current one, right? If num's index is smaller, right? If num's index is smaller, actually we don't have to compare. We make sure that every time we pass, it has to be larger. So we're gonna say what we're gonna say is current gonna be append index, right? Current gonna append index, and current gonna append index, and then what we're gonna do is no. We're gonna check the target, right? We're gonna check the target and say if the target, dang it, current target minus equals, that's index, it's num's index, right? So current plus this and minus num's index, right? So, and then we're gonna say for the remaining, we're gonna pass. Say for I in range index plus 1 to n. So we're gonna do an n equals len nums. All right. So in this range, what we're gonna do is helper, right? Helper index I, right? Current, and then current target. Yeah, actually we do this index. Yeah, do it. We don't have to change it here. Right. So when I do a helper, and then have the helper come back, that's fine. So we'll pass the same current, and then when we go all of this and then current.pop, and then we have to go back to the previous, because yeah. And then further, when check if current target is equal to 0, right? Equal to 0, then we say rest.append current, copy it, and elif current target is larger than 0, then we do this. If it's smaller than 0, then we don't care, right? We don't care. And we're gonna say here, what do we do? Should we? Yeah, I think we should. It should be like, hold on. This doesn't feel right to me. This one doesn't feel right to me. I don't think this should be an index. There's no index. We always pick everything. We always pick everything. Yeah, we always pick everything. And then after we pick, so we take, there's no index. We always take the front, right? We take the front. Yeah, we take the front. right? We always take the front. Hold on. We take, so we pass in, right? We pass in, and then what? Then we take the first one, and then go with the rest. We take the first one, right? And then we take the second one. So I think it should be here, right? So we say current.append nums I, right? And then when we're done, then we pop it, and then we try the next one. That looks more likely. Okay, let's try it. Helper. Let's start with this. Target equal target, and then when they return len res, right? Not very confident. This feels a little bit weird. So let's take a look. So this one's gonna be 4. And number 7. Okay. Next one is 9. It's gonna be 0 and no, it's 3 and 0. Let's try it. Nums target answer. This one will be combination for nums and target. Index is not defined. I have an index. Should be I. Helper takes 2 position, but 3 were given. There's no I. Oh, they pass. Okay, I guess maybe it's correct. Let's try one more. Let's try something that we can pass, like 1, right? This one shall be 1. Yeah, and I don't know. Oh, unique. All right, let's try. I don't know. What are you thinking about? 15. Oh wow, that many. Judging. Oh no! Oh no! We hit a TLE. Ay ay ay. Time limit exceeded. Ay ay ay. I don't think it's this one. This one shall be fairly fast. Right? 421 32. That. Oh no. Oh no. This one's a lot. Oh my goodness. We need to. Okay. Yeah, I thought. No. Okay, time limit expires. Yeah. That's true. Like, we keep running. Like, we go all the way down, 4 all the way down, and then go into 2. So I think we are solving the same problem over and over again. Which means, I don't even know what's the result here. I don't know. Let's call it 10. So helper current list and a target. Can we just, no, I really cannot go, I cannot catch this one. Let's just say with, yeah, like with a target, I shall have the number already, right? What we shall do is to count the number that I can achieve while we're doing it, right? So we want is 32. Like this one will give me 32. we can go the other way around. So we start from 1. Right, 1 is just 1. 2 is, maybe that is the way. Right, 1, if it's 4, 2, 1, right? 1, we have 1. 2, well, 2, because 1 have 1, so we can find 1 plus 1 and 2 plus 0, right? And it's unique. So we can see if 2 is there, 2 plus 0 is working. Yeah. And then 1 plus 1, and 1 is, so multiply, right? Is it multiply? Like we have, say we have like n ways to get to one value, and we need n ways to get another value. So how many in total? Well, like we can pick A, B, C, and we pick A, B, C, and then they have to put them together. I just say A, B, and A, B, right? A, B, and A, B could be like first could be first position has to be. No, this is actually permutation, right? You put these values together. It's 4, and it's a permutation. No, it's not permutation because the values are the same. Like AABB, right? So like AA. How? Hold a sec. Let's go back to this one. We're changing the idea. So 1 is 1. 2, we know there's 2 exists, so that's 1. And then 1 plus 1. So 1 has 1 way to do it. So it's going to be 1 way. And then there's only 1 way. So 2 has 2. 3, we have 1 by itself, right? 3 plus 0, 2 plus 1, 1 plus 2. But 2 plus 1 and 1 plus 2 is the same thing. So we just do 3 plus 0, that's 1, and 2 plus 1. Now 2 plus 1, 1 we have 1 way to do it. 2 we have 2 ways to do it. One is 1 plus 1, the other is 2 by itself. So it is multiply them together, right? It is multiply them together. Not really, because I can change the order. Now that is, unless we keep going, like 1 plus 2, right? 1 plus 2. Because we are shifting them. So, but there's still going to be duplicates. So if we do 2 plus 1, right? We have 1 plus 1 plus 1 and 2 plus 1. But we don't have 1 plus 2. That is the trouble, right? That is the trouble. We don't have 1 plus 2. 1 plus 2 only exists if we do 1 plus 2, which give us 1 plus 1 plus 1 and 1 plus 2. And then now we have duplicates. This is not as I had expected. I mean, what can we do with this? Oh, and also 1, 2, 1. No, that's we haven't reached there yet. Anyway, so if we don't, like, no replicates, and this one has 3, right? 3 has 3, which is 1, 1, 1, 2, 1, and 3. 2 is 1, 1, and 2. 1 is 1. So then 4. Right? 4, we can do 2 plus 2. We can do 1 plus 3. 4 plus 0. We don't have 4, so 1 plus 3 and 2 plus 2. So 1 plus 3 will give us 3 different. Right? So 1, 1, 1, 1, 2, 1, 1, 3, 1. And then 2 plus 2 will give us 1, 1, 2. Right? And then 5 gives 1 plus 4, 2 plus 3. Right? So 5, 1 plus 4, basically just 1, 1, 1, 1, 1, 2, 1, 1, 1, 3, 1, 1, and 1, 1, 2, and 2, 1, 1 is the same. Dang it. So the 4, we have an issue with 4. 4, we have, holy moly. We have 1 plus 3. And we need to order it, right? We order it, always have the smaller one goes first. 1 plus 3. So we have 1, 1, 2, and 1, 3, right? And then we say we'll have 2 plus 2. 2 plus 2 is 1, 1, 2 as well. And we have to eliminate it because it's not part of it. Oh, this is not as easy as I'd expected, because these things, and then you have to also like the way I'm doing right now, I can figure these things out, right? But after I figure these things out, I already got 4. Okay, I already got 4, but that's 4. That's unique ones, right? It's unique ones. We also need to find a combination, like 1, 1, 2. A combination of 1, 1, 2. It's not combination 1. It's the permutation of 1, 1, 2. But permutation 1, 1, 2 is going to be a lot. And now we have like 2 values are the same. Oh, where's 2, 2? Yeah. Yes, it's 1, 1, 2. Oh, it's also 2, 2. I forgot about 2, 2. It gotta be a systematic way to do this. Hold on, let's try it again. Let's see if we like systematically do it. What's gonna happen? So 1, 1, 2 is 2, right? Or 1, 1, 3. We have 3 by itself, or 2 plus 1, 1 plus 2. So we have 1, 2, 1 plus 2, 1, 1, 1, or 2 plus 1. 2 plus 1 will be 2, 1, and 1, 1, 1. And then we say 1, 1 is occurred already, so we don't repeat that. Now 4, we have 1 plus 3, which is 1, 3, 1, 1, 2, 1, 1, 1, 1, 1, 2, 1. Right? So 1 plus 3. Now it's 3 plus 1. Now 1 plus 3, right? And then 2 plus 2. Now 2 plus 2 is, we have 2. Oh man, 2 plus 2. So it's going to be 2 and 2, right? 2 plus 2, 2, 2, and then 2, 1, 1, and then 1, 1, 2. Well, 1, 1, 2 already there, so we don't do 1, 1, 2. And then finally, 3 plus 1, we have 3, 1, 1, 1, 2, 1, and then 1, 1, 1, we already have it. 2, 1, 1, we already have it, so that's it. So it's 1, 2, 3, 4, 5, 6. Oh, 1, 2, 1, we already have it, so that's 7. Is that like faster? Okay, then it's gotta be faster than this. All right, let's try a different. Oh my god, this is completely different now. So we're gonna start from 1 and then try to build up. But that is still going to take, like, every single time we have to go through all of them, right? God, I'm afraid this might time out as well. Anyway, let's try it again. So we have a result. Oh, not really a result. We are going to nums length. So do we do nums? Okay, we're gonna do nums bucket, right, equals 1 if no. It's gonna be just a 0 for in range. No. We know that maximum is 1000. Right, so probably have to do 1001. And then we say for any nums, right? Then nums bucket and put 1. So that's just for us to easier to detect, right? And then we say, oh, we need to save. I need to save all of them. No, this is not gonna work. You cannot save all of them. That's gonna be a lot of things to save. Like it's. I mean, we cannot like determine the number. Like 3 is, we have 4 different ways to do 3. We have 1 way to do 1, 2 way to do 2, 4 way to do 3, 7 way to do 4. It is adding them together, huh? No, it's not adding them together. That's just a coincidence. Like the 4 way, because we have 1 way to do 1, 2 way to do 2, so we say there's 1 times 2, right? That's 2. And then we have 3, that's actually 3, but because the 2 ways to do 1 plus 2 is also 2 plus 1. How do we handle it? Like if we know a number has a certain ways to do it, do we know the next number? Like we know 3 has 4 ways to do it. How about 4? Well, it is, I mean, it also depends on the input values, right? So for 4, I can look at 3, right? So 3 has 4 ways to do it, and 1 has 1 way to do it. So I say they have 1 times 4, they have 4 ways to do it. But if 1 has multiple ways to do it, you cannot just multiply them together because there might be duplicates. There will be duplicates. So if you just like simply say Because you say 1 plus 3, you can also say 3 plus 1, right? Possible combinations. I think we have to change the idea. This is another way to go. So again, 1, 2, 3. Let's see what's the result of this one. It must be a gigantic number. The result of this one is, oh Jesus. No, it gotta be some other way. So we go from small to big, right? 1, 2, 4, right? 1, 2, 4. So we say target is 32. The most number of ones you can get, right? Which is 32 ones, right? So that's the first one. And then we take one out. So we have 31 ones, and then we cannot do because the next one is 2. So now we say, how about we have 30 ones? And now we can add a 2. So I have 30 ones and a 2, but the result is not one way because the 2 can be placed at any location, right? It can be placed at any location, which means how many locations does it have? If I have 2 ones and then have 1, 2, so that's 3 positions. So it's n plus 1. So it's going to be plus 31, right? And now we have, say, 29 ones, but we cannot do because 29 ones how do we do this? We start removing ones, right? We start removing one, so we have 30 ones and then 29 ones. 29 ones we need, well, we need 3, but we already have 3. Hold on. I want to keep thinking, but I need to feed my cat. I was feeding Jimbo, I just had a new idea to solve a problem. Try it. Try. Cold. Alright, I'm back. As I was feeding my cat, I have some new idea. Well, looking at this, right? The ideal is we say we only involve one, right? And then we find all the combinations that 2 and 3 can form target 3. And once we find it, and then we just consider all these combinations as one entity, and a 1 is just can insert like into the left or the right of that entity, or I should say the entity insert to the left or right of 1. Right? For example, I think so. We have 1, 2, 3, right? And then we decide we're only gonna have 1, 1. So we need 2 and 3 to give us 3, right? And then that means we also secure 2, and then which means we need what? 3 to give us 1, which we cannot do. So we cannot do 2, so we do 3, and then we say 3 to give us 3, and then we're good, right? We're good. So this tells us that 2, 3 will have only one options, right? One options, and then that means going here, we can put that option at this position, like 3 can be at this position, or 3 can be at this position, which means however many we have, we're going to times 2. All right, so we can put it here, 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 so times 2, which means 1, 2, 3, we'll have 1, 1, right? Only 1, 1 will yield 2 different options, which is 1, 3, and 2, 3, 1. Yeah, that's including 1, 1. And now we try 2 1s, right? 2 1s, and then actually when I have a 2, then we 2 can plus put it here, put it here, put it here, right? 2 1s going in, that means the target is 2. And then we have 2, 3, 2 it works, 3 doesn't work, right? So we only have one option, but one option coming back because it's 1, 1. So with this option can put at 3 different locations. So that's 3, right? So I have 3. Now we have 3 1s. 3 1s coming in, and remaining is 1, which doesn't work. So 3 1s doesn't work. Now 4 1s. 4 1s, and that's already 0. So we have it. So 4 1s 1, right? So that's all the 1s involved. Next, when we consider no 1s, only 2. So 1, 2, and we have a 3 to give us 2, cannot do. 2 2s, 2 2s, good. And then nothing more. 3 cannot do. So that's, yes, that is the solution. That is the solution. We need to rewrite this. All right, rewrite this. We don't even need yes, we don't even have to save anything, right? There's no list, nothing. We just need a current value. Basically, it's a current value we're passing in, and we determine, actually, we probably need a repeat, right? Let's see, repeat, and we're doing a current value and a repeat. Okay, so we have repeat as an int, and we have a current and an int, and we have a target, right? So when we start on the outside, we just want to say we want a 1 1, right? Okay, how how do we solve this? So we say when we do this current, what does current even mean? No, I think it has to be index, right? Yeah, it's actually index. It's index. It's index. I'll be back. All right, I'm back. Let's keep working on this. Okay, so yes, it's index, which means we have index, we have a repeat, and then we move on to the next index. Exactly. Exactly. Do you want to sort it? That'll be even fun if you sort it, right? Yeah, I think it'll be fun. Like if it's 4, 2, 1, I think it'll be more fun to do 1, 2, 4 instead of 4, 2, 1. I suppose it's the same, but I want to sort it. I mean, it doesn't hurt. I want to sort it. So we have repeat of index, right? Then we are going to decide. What are we going to decide? This one I'm going to return int, and we're going to cache it. So from functools import ARU. Oh, it's not functool? Yeah, cache. So we're going to say here at ARU cache, I think have a max size equals, I think it's a none, right? I can do none. I'm not quite sure. Let's try ARU cache. Where's the documentary? Jeez. Cache. I think max size we can set to none. Can grow without bound. Yeah. We wanted to grow without bound. All right. So now we can solve it. So we have an index, right? And then what we do is current target. We're gonna say we have a repeat, all right? So actually we don't have to do repeat. There's no repeat. It's an index, and then we're gonna try to repeat. For R in no rep equals 1, right? We have to repeat once. Yeah, we have to at least repeat once, and then we say while rep times nums index, right? While this is smaller than current target. All right, if it's smaller than current target, then we can do it. How do we do it? We say, right, what we say is helper index plus 1 current target minus rep times nums index, right? We try to solve that, and after solve that, we're gonna get a response, right? We're gonna get a what should we say? Let's call it temp, right? So this is that, and then we're gonna have a res equals 0, right? And then we say res plus equal to temp times what? temp times repeat plus 1. That's what I think. Yep, repeat plus 1. Rest time. So we have repetition of that value, and then the result, however many ways you can have, and we can just insert into every single position. So we have this many times, this many times. Yes. So the result, I'm gonna plus equal to this, and then after do that, I'm gonna rep and plus equal 1, and go back again, right? Go back again and again until we exit. Now, when we exit, we need to check if rep times nums index is, hold on, we can actually do equal equal, right? Yeah, we can do equal equal, and then if it's 0, then we just return 0. Yeah, we can do equal equal, not equal, we're going to do smaller than equal, right? And then comes back up if that's fine. So now we have the result, right? And then we just return the result, right? And then we cache everything just in case. Let's see it one more time. So for each value, we grab one repetition, start from one repetition, and we basically say 2, 3, and they give me however many you can, and then when I call this again, now the index comes here. All right, now I'm going to say one repetition, which gives us 2, which is fine. Then temp, when it comes here, come to 3, and current target is 2. No. Current target is 3 minus 2 is 1, right? So it's 1. So current target is 1. Now this does not work, so it turns to be 0. So which means that temp is 0. So that's 0. And repeat plus 1. I think this might work. This might actually work. And here, what we need is a res equals 0. When you say for I in range len nums, right? When I say res plus equal to helper I target, right? And then we're going to return res. All right, let's try it. List index out of range. Okay. So it has to be what? So rep times. So the 3. Why would it be out of range? Because 111 index plus 1 comes back up. Okay, so let's do n equals len nums, right? Then we're gonna say while index is smaller than n and this, right? And then this one gonna be n. Okay, terrible. We don't get anything. Huh. Let's take a shot, take a look. Okay, we didn't get anything. Why is that? I mean, we run the first round. All right, this probably needs this. All right, we are going full on. 3, 2021, 04, 0419. All right, let's take a look. We're gonna start from, I think it's T, right? And then S, N, 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 okay. N, N, N. Okay, so currently we have I is 0, N is 3, rest is 0, target is 4. So we enter, right? So we enter here. Current target is 4. Rep is 1, result is 0, and then index is smaller ES. ES temp, okay, equals helper. Now it's 3 because I'm minus 1, right? There's 1. This one's good. Oh, should be 1. Yes, current target is 1. Here, index is 2, so that's fine. Rep is 1, index 2, so it's 3. 3 smaller equal to 1, that's not right, so we return rest, so return 0. That's fine. Okay, so rest plus that's 0. Coming back up. What's now? And then coming back up, the rep is 2. Oh, if 1 rep doesn't work, then 2 rep can definitely not work. So actually, we should also like do that as well, right? If like multiply once doesn't work, no, it might work. Anyway, so it's just say it's 2 times 2, right? So 4, so that's not working. So I'm gonna return 0. That's fine. Return 0. So now we go back, and it's 3. Rep is 1. Index is 0. So rep is 2. Hold on. Hold on. That is not correct. What it's saying is 1, 1 will give us no result. Ah, I see. I think I know the problem. The rep has to start from 0. Have to start from 0 rep, right? And then go to the next one. Yeah, has to start from 0 rep. Try it again. That's this. Yeah, 0 rep, still not right. So 0 rep, no, it has to be a 1 rep. So we want to have 1, like 1, 1, right? 1, 1, why we cannot get 3? It's because at 2 and 3, so we got 2 and 3, we said we must have 1, 2, but actually we don't. Hold on. Hold on. Hold a sec. When we secure 1, right? 1, 1, and we say we want a 1 repetition, 1, and then we go. That cannot be index plus 1. This has to be 4 I in range, index plus 1 to n, right? It has to be this. It has to be this, because that means that we're going to do, put in 2, we say we're going to have 2, right? And then we say, after this is done, we say we're going to have 3 by itself. Yeah, which means this one's going to be I. which also means this is going to be smaller than n no matter what, because I is like this, so we don't need this. I don't think that's going to be out of range. So it's going to be this. I think the rest is the same, right? So this. Hold on. What about the rep? No, the rep has to be here. This is a one rep, right? There's one rep, 1, 1, and I want to check on 2. We must include 2, right? We must include 2. And then that done is 1, 1, and we must include 3, right? And then we're done, and then we say 2 ones. Try it again. What the hell? It's still not correct. That is not right. I already say index, right? Index plus 1 start from 2. So that's 2, that's right. And then go back. Go back. Index should be 2, which means come here, index should be 2, and nums 2 should be 3. That should be right, right? 3 smaller than this. And then check, we cannot do. And then rep. What did you count? Yeah, I found out that we don't have a count. Smaller or equal to. And then it's 1 rep times 3, smaller or equal to 3. Yes. Go on here. Doesn't work. Yeah, we don't have a mechanism to actually add the result. Which means I think, because I say this is smaller or equal to, and then I cannot keep going. Alright, I cannot keep going. And I rep plus 1 and I escape, and the rest never changes. Which means I think it should be smaller, and when we get out, we're gonna check. Check what? Rep times nums index. If it's equal to current target, then res plus equal 1. There we go. Now we pass. This one will pass. Try this one. It's not correct, but we're getting better. It's supposed to be a gigantic number, but we have a tiny number. Okay, so we're getting closer. Number 4. Now the question is why it failed that way. God. Let's do an easier one. Won't cause too much trouble. Let's say we have actually I probably need to do the LRU cache as well. Right? And then we say let's just do 8. Okay, probably 4. 4 is correct. So 8. All right, so we do 8. So ignore this. I have a new one, which is 8. Supposed to give us 55, but our answer is not correct. All right, let's focus on this 8. What we can do is we can, just can we do the audio cache? Can we print out anything? We always just let's print here. Print what? Index, current target, and the rest. All right. So index, and that's not the index. Let's just do 1, 2, 4. It will be easier for me to check. All right, 1, 2, 4. Oh, actually no. Oh, actually yes. And then instead of press index, let's just do nums index, which means this is the current value I'm checking. Right? So I'm checking for 5, which gives us 0. So that's I take 1, right? I take 2, and then that's no good. And then what's this? Also at 4. So take 1. Let's give us 7. Right? Give us 7. And then we can take 2 2s. Right? Still not good. And take 1, take 3 2s. That's still not good. So no good. So which means I'm going to take 1. Already take, so I'm going to take 4 directly. 4, this will be 7. Take 1, 4. I don't understand. I do not understand the logic here. Hold on. So we have 1, right? We take 1, 1. Rep is 1. Then I say we take 2. So we have to involve 2, right? Involve 2, right? Coming in, so we involve 2. So first 2, and then we're going to go involve 4. So yeah, that's 1, 2, 2, 2, that's 3, 2. 1 and 3, 2. Yeah, but after it's done, which means I take 1, 2, 2, 2, 3, 2, when it's done, coming back, it's here, right? It's not working, going up. I shall go 4, right? I shall go 4. All right, I shall go 4, and nums and plus 1, so 1, 4 doesn't work because this one didn't even go through. The 4 didn't even go through. Rep is 1, nums that should be 4, right? And then it didn't go through because index currently is 2. Now it's 3, so it's now plus 1. And then now we exit here. I shall see a 4 and 7. But I have a 2, 7 here. Hold on. It's necessary that we go here again. Okay? Yeah, it's no shame. It's just, we got stuck. Normal play. Alright? Okay, I is 0, n is 3, target is 8. Let's go inside. Plus rep. Okay, rep times this nums 0. Num 0 is 1, right? And this is going to be 2. So we're going inside, so 7, yes. And keep going. 5. Yes, so it's 1 plus 2 is 3, so 5. And we currently at index is 2, which is 4. 4 times 1, that's actually good for times 1, right? And then I'm going to try again. Oh, but it does not try again. Oh, I pressed the wrong button. It's a 4, right? 1, 4, so it's going to be 1. 1 will actually go, it's 4, 1. Yep. So that's fine. So rep current target is 5. So rep plus 1, and then we don't do it. And then we print. And then return. That's a 0. It's fine. So now target is 7, and we're at 2. I is 2. Yes. So I is 2, that means 4, right? So it doesn't work. Now it doesn't work. Rep plus 1, so rep now become 2, right? So 2 times 2 is 4, smaller than 7, so I'm going to try it again. Okay, so go inside again. Now target is 3, so this one shall exit immediately. So return 0, that's fine. Now wrap gonna increase again. No, not increase, we'll do this. Then wrap increase. Now wrap is 3, 2, 3 is 6. So we can still do, but this one will still fail. Right? Temp will still be 0, and then rest is still 0. Come back up, wrap. Now it's 4. 2 times 4 is 8. And it's smaller, no. So we come here. And that one is no, good. So return. All right, now go back to the beginning. Turn targets. So which means go with 2 didn't work. Now we're gonna go 4. Right? Now we're gonna go 4. Target is 7, index is 2. Yes. So 4. We can actually have an easier way when there's only 1. Right? We can actually have an easier way. So anyway, 4 and 7, that's going to be a no good. So 4 is going to be no good. Wrap is 2, and that's no good. All right, turn. So that's still 0, which means 1 with 2 and 4, neither is good. I mean, only 1, 1, right? So now we're going to try 2 1s. Okay, 2 1s. If it's 2 1s, now we're going to have 2 1s. We'll have a 2. We can do that. 6, right? I have 6 left. And we say we need to do 1, 2, okay, which gives us 4 left, right? Which this one shall exit. Rest plus 1. Yes. Turn. Good. Which means we pick 1, 2, then we can put 4. And we can do 4 on either side. Right? We can do 4 on either side. So we say rest and plus equal to 2. Rest is 2. Now we're going to do 2 2s. But 2 2s, which give us 4. And then that's 2 left. So that's going to be temp. No, that's like nothing. Didn't really add. And then 3 2s. 3 2s shall exit. No, that's 2 2s. 2 2s. 2 2. We can do it. But this one shall give temp shall be 0. Yeah. And the rest is 0. And then next one cannot go. Now it's 3, 2. This one shall exit. So we can actually say with 1, 1, we get a 0. With 2, 1, we have 2 and 4, right? 2 and 4 will already give us, that already give us 2. And then this one shall give us another, well, this is just like 3 2s, right? So give us another one. Now we return 3, right? Return 3. So 2, 4 give us 3. It's 2, 4, 4, 2, 2, 2, 2, right? Give us 3. Now when it give us 3, temp is 3, and then repetition is 2. So we can put 3, we can put here, put in the middle, put in the front. So that's 9, all right? The result is 9. Yeah. And then that count to 4. Now we can do 1, 1 is only 4. 4 is going to be, no, that's no good. So we can just directly go temp is 0. No good. No good. Now that's it. That's the 2, 2. Now we have 3, 2. 3 goes 5. That's actually no good. I don't even need to check. That's going to be no good. Yeah. Now it's 4. So 1, 1, 1, 1. That shall give us 4. So that one's a good. So 4, I shall expect 2, 2, 4 will give us what? 2, 2. Right? 2, 2. That's about it. And then a 4. So one from 2, 2, and the other one from 4. Alright, so that shall give us 5 different ways. Temp 1, right, rest shall be plus 5. Yeah. Then this shall also give us 1 with plus another 5. It's 19. And then this one shall give us 0. 6. 6 shall give us 1. Yeah. So times 7. So it's what? 26. Then next one is no good. Right. And now is 7. 7 is no good. 8. 8 come out. Without plus 1. 27. Yep. Coming here. All right. Now, index I, so 27. 27 is total that involving ones. Right? 27 total involving ones. And now, coming in, okay, let's enter this. Index 1, so we have 2. 2 at the start, right? 2 at the start. What result did you get? Like 30 something? 2 at the starts. Okay, so for I, so now I is going to be 2. Yeah, that means 4. Temp can be this. So that's 6. That's no good. Coming back up, nothing. 2, 2, that's 4. Right, that's 4. That should give us 1. Yeah, so that shall give us 3. That should be 3. Yeah. Now we have 3 2s. 3 2s is no good. 3 2s is no good. Because 4 cannot do. Now 4 2. 4 2 coming out. Plus 1. This gives us 4. This gives us 4. So 2 involving 2 will give us 4. Involving 1 give us 27. Now involving 4 should give us 1. That's our result, 32. Okay? I don't see any trouble with this, but that's not the result. Result shall be 55. And our result is what? 32. Okay, that's no panic, no panic. We just hit another roadblock. But I kind of think we are on the right track. Therefore, we're just gonna keep digging. Let's take a look, take a closer look at all the possibilities. Like not involving 1, right? If we have only 2 and 4, do we have, say, if we only have 2 and 4, let's try it. If I only have 2 and 4, right? How many do we have? Only 2 and 4, 1, 5. That is correct. 2 and 4, we only have 5. But 1, 2, and 4. 2 and 4 have 5 ways. That's exactly what we have discovered, right? That's. I think it's about. I think I know why. Because if I have 1, then I have whatever. That's 2 places to put. I have 1, 1. Whatever I have 1 place. That is the thing. If I have 1, 1. That's 2, right? 1, 1 is 2, and I have 6 left. And then we can have a 2, 4, right? So we have 2, 4, 4, 2, and 2, 2, 2, right? And now we have 1, 1. Currently, the scheme we do is 1, 1, 2, 4, 1, 2, 4, 1, 2, 4, 1, 1, right? And then that's only 3. But in fact, there's also 1, 2, 1, 4. That's the one we're missing. That's the one we're missing. How do we... So basically what we're saying is, man, like how many different combinations can we have? We have 2 and 4, right? That is getting difficult because I return is just a number. I know there are like 3, right? I know there are 3 ways. And I can put them around. But I don't know in particular, I don't know in particular how they shall be, like, I need to know the length of each. Okay, so what we can do, like this is one way, right? We do all 3 positions, right? Now we got 3. But we can also keep that stable, like 2, 4 stable, and then we insert 1 in between, right? So instead of 1, 1 as a unit, we split 1, so we can put 1. How do we split? How does that work? We have we have 4 positions, right? The first position we can call the choice is 4. We have 4 choice on the first position. And then we have 3 choice on the second position. But that's if they're all different. So we have 3 choice on the first position, right? And then if we choose, let's say, it's 2, 4. We can do 1 at each position. 1, 2, 4, 2, 1, 4, 2, 4, 1. And then I want to insert another 1 into it. Right? We can insert ahead of it, right next. But these 2 positions are the same, right? So what we can only do is, but then we have repeats. Like 2, 4, if they're together, we don't consider because we already consider all of them. We just consider we're gonna insert in between them, right? So what we can do is we can put both in between them, or we put one in between them and the other on either side. Right? Okay. So that makes it 6. And 4, 2 is the same. So what this means is, given any number and I can insert in between you, like I insert in between any pair, and then I can insert in another pair. What if I have 3? 2, 2, 2. How do we handle 2, 2, 2? So 2, 2, 2 is a unit, 1, 1 is a unit. We handle it. Now we say 1, 1 is a unit, then we insert in between 2, 2, 2. So we have to split 2, 2, 2 up, right? So we need to put 1 in between, right? So 2, 2, 1, 2, yeah, in between. And then we need to insert another 1. It could be at any position because we're already inserting it. So we can insert any position, this, 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 this. But then we have repeats, right? So we have 1, 2, 1, 2, 2, 2, 1, 1, 2, 2, 2, 1, 2, 1, 2, 2, 1, 2, 2, 1, right? So 1 is inserting 1, 2, 3, 4, 5. It should be 5. 1, 2, 3, 1, 2, 3, 4. 4 different positions. And then in this, the other scenario, the 1, 2, 2, 1, 2. Right? And 2, 1, 2, 1, 2. That's a repeat. 2, 2, 1, 1, 2, and 2, 2, 1, 2, 1. So we do have repeats. This comes up to 1, 2, 3, 4, 5, 6, 7, 7. That's 7 plus 2, 2, 2 are all together. We have like what 2, 2, 2, 1, 1, 1, 2, 2, 2, 1, 2, 2, 2, 1, 1, 1, 2, 2, 2. Basically, this is another problem. Like we have, like, how many unique permutations do we have? Unique permutation. Unique permutation. Is there a faster way to compute unique permutation? I'm going to cheat. I think ITA tools might have unique permutation. Permutation. R length permutation. I don't think. I don't know. Let's try list permutation. What? Let's say 1, 1, 2. Oh, I forgot the and. 1, 1, 2, 1, 2, 1, 1, 1, 2, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1. Yeah, that does not take away the unique ones. That makes it very hard now. I don't know, like how to compute unique permutation. Like, well, we don't need to know like what numbers it is. We just need to know how many uniques there are. Man, but that is a lot of computation. And I want to just return a number. But apparently you cannot do just a number. No, you cannot do just a number. But you cannot hold all of them. Look at this result. This is huge, right? The result is huge. We're talking about like what 398, what 39 million. The result is huge. There gotta be a way. But I'm facing with this dilemma. Like I don't know what is the like faster way to do this. And I don't even know if this is or unique. What's the total of this? 1, 1, 1, 1, 1, and 2, 2, 2. We can actually do this. Just kind of check. 1, 1, and then 2, 2, 2. And then we say set. And then we do a len. Should be 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, we do get all 10. But what is the rule for this? There's no rule for this. And then 1124. 1124 is 12. 1124 is 12. One one two four is 12. Did you get 12? Actually, I think I'm gonna get 6. Oh no, that's 12. Yes, so 1124, 1142. Yes, that's 12. How did you calculate this? Two, four, like the that's together. The 1 1 is a repeat, right? 1 1 is a repeat. So we can like insert 1. So given any, let's say ABC, right? We can insert 1, and then after insert 1 on the front position, I can insert another 1 at any of the remaining positions, right? Yeah, I can insert 1 at any of the remaining positions. So that gives us. Now we can also insert at the same position, right? Same position, this, or this. This is a 1, 2, 3. That's 4 different ways. And then I can move the starting position is here. Then we can go also all 4 positions. That's 4. This we have 4. Last one we have 4. But we have to minus 4 because we double counts. The full, we have double count each time, so that's 4. So this gives us 12, which means if we have, say, 2, 3, 4, that shall give us 12. No, that's 60. Yeah, yes, that is 60. No, so 60, yes, we only care about like by itself. Only care about by itself. Like 2, 3, 4 cannot change. So we just divide it by 6. Right? So 2, 3, 4 divided by 6. And that should be 10. So we have 1. See, right? 1, 1, 1A, 1B, C, 1A, B, 1C, 1A, B, C, 1. Right? That's, yeah, that's 4. Now we have 1A, 1B, C, A1, 1B, C, A1, B1, C, A1, B, C1. Alright, and then next position here, right? So A1, B1, C, 1B, 1, 1, C, A, B, and then A, B, 1, C, 1. Right, that's another 4. The last 4 is one A B C 1, A1 B C 1, A B 1 C 1, A B 1 C, no, A B C 1 1. All right, and then we have repeats here. One repeats here, and then 1 A B 1 C. Repeats will happen like here. That's a repeat. Okay, 1 A B 1 C, we shall see it too. 1 A B 1 C, yeah, 1 A B 1 C. But 1 1 A B C is not. Right? And then definitely A1 B1 C, yeah, that's repeat. And A1 BC1 is a repeat as well. A1, B, C1 as a repeat as well. Oh yeah, the repeat will be like if it's a start, it's gonna repeat. Let's reserve these. Yeah, that's like and then anything here is gonna be anything. This is going to be repeat, and then anything that has it because the one's already inserted here. So this and this and this, so it's gonna be here. So it's gonna be 1 plus 2 plus 3 plus 4. That's 10. Yep, that is 10. That is 10. And then you have A, B, C can change. Okay. So that means given two solutions, right? So 1, 1, we have 2, and then we have 4. Let's give us 1. Right? Hold on. We check on 2. Right? After we check on 2, 1, 1, we check on 2, and we check on 4, and that's good. And coming back, yes, we don't even have 4, 2. We only have 2, 4. So we come up is one solution with 2 values. One solution with 2 values. And we know the 2 values are different. How do you know that? How do you know that? I don't. I mean, with 2 values, we can do the same trick, right? Which means we're gonna have, if the 2 values are different, then it's basically 3 plus 2 plus 1, right? It's 6. 6 different combinations by putting 1 into it. And then itself can do permutation as well, which times 2, that becomes 12. Now 2, 2, 2, I mean, when we come back, we probably need to return something else, right? We need to return we have to return a solution. So 2, 2, 2, how do you handle 2, 2, 2? Well, 2, 2, 2 is going to be 10, and it just doesn't have permutation by itself. Right? 2, 2, 2 doesn't have a permutation by itself. What if we just return the unique solution and then we simply just compute it? I mean, maybe it's not too bad. I mean, we have 1,000. I don't know, man. It's like if we have, say, a lot of this. Yeah, it's gonna take a long time. So the repeats we don't compute, but the remaining we compute. But in the future, you're gonna have remaining. You're gonna have remaining is gonna repeat a lot of times. All right, I think it's time to give up. And we failed again. We do have a TLE. Yeah, let's get a TLE out. Yeah, we at least can say that, well, we tried, but we didn't get it. TLE. Man, this one is not simple. And then I'm gonna cancel it. Come on. Alright. Terminate it. I think CPU. Yeah, this is the one. Ooh, let's quit it. Oh yeah, now I quit everything. It's terrible. Go back. No, I think it's actually on the desktop. Yep. No, not this one. Alright, let's just take a look at the solution. I got stuck. I got stuck on the permutation things. Problems. If we can work on some hints, that will also be helpful. Oh, it's a medium question. That's a medium question. Man, did I think about like too hard on this? I might have done it before, right? No, I have not done it before. No, that's not the one. DP, dynamic programming. It's not a hard. Dynamic programming. And the thing is, just I can't figure out how DP can help. I mean, we are doing DP. I mean, this is DP. We're trying to do DP, but just this step is not correct. It's not simply temp times this. It's more than that. And just how do we... I can't even solve the 1, 2, 4, 8. Add up to 8. Okay. So 1 plus 7, we say 10.1. Yeah, like even if you find like how many ways, but what do you do with those ways? You cannot multiply them. You cannot plus them. You have to analyze them. All right, it's taking too long. Let's take a look. permutation sum. Anyway, that's it? Oh shit. Oh yeah, that's the recursion. Oh man. Okay. And small end. Number of combination target equals sum combination target minus number of combination 4 is a combination 3 plus combination 2 plus combination 1. Combination 3 plus 1, other combination. Combination 0 is 1. If there is already a result. That's it? You don't have to consider combination sum nums target minus nums I. Yeah, this is definitely not working. Hold on. What are you saying? If we know a target is the sum of numbers in the array, imagine we only need one more number to reach the target, okay? We need only one more. So we just minus that value, right? Minus that value. Which means the combination, we say we need to reach 4. That is the total combinations of 3, like 3 plus 1, then that's that, right? And then total combination of that will reach 3, because if we do that, you only need to add 1. But don't you have to consider like where they're placed? We don't have to consider where they're placed. Wait, what? Combination 3. Like all ways that we can reach combination 3. But then what do you do with the remaining 1? Wait, seriously? Rest plus combination sum nums target minus nums I. So where do I put nums I? Let's run this algorithm. Let's see. Where did you get stuck? Well, I have 1, 2, 3. I want to make 4, right? And then what it says is, okay, so target is 4, is larger than 1. So the result is going to be 1, 2, 3. We want to make 3. All right, we want to make 3. And then it's become 1, 2, 3. We want to make 2. And then it becomes 1, 2, 3. We want to make 1. Now it becomes 1, 2, 3. We want to make 0. And we say if we want to make 0, that's always going to be successful. So 1, 2, 3 makes 0. Not 1, 2, 3 makes 0. Just the target is 0. If the target is 0, that means we get 1, right? So basically it means this will return 1. So this will return 1, right? This will return 1 back here. Now we're going to try 2. I'm going to try, so we have 1 already. Hold on. We want to do 1, 2, 3. We want to get to 2, right? So what do? We say that's equivalent to, we want to add a 1 to it. So we need to do 1, 2, 3. That can give us 1, right? Which means now we have 1 plus 1, right? Now we want to get 2. So that's 2 plus 0. So that's 2. So we'll have 1, 1, and 2, 2, 0. Coming back up to 3. That means if we do 1, we have 2 scenarios, 1 plus 1 and 2 plus 0. Oh, because when we consider 2, we are consider 1 again. So that's how we get 2 plus 1. But how do you avoid repeats? And we have 3, right? So we have 4 different ways. With 4 different ways when we remove 1. Now I'm going to remove 2. Yeah, so we have 1, 1, 1, 1, 2, right? And so 1, 2, 1, so we have a 1, 1, 1, 2, and 1, 3. That's when we say we take 1, and we want the remaining to give us 3. We take 1, we want the remaining to give us 3. Now we say 1, 2, we want the remaining to give us 2. Oh yeah. If we want 2, means the first letter is always 2. Oh, that's the trick. That makes sense to me now. That does make sense to me now. That's how you avoid. So the initial ideal is correct, right? We just pick the first one. We set the first one always. We set the first one, and then we find all possible situations for the remaining, right? And then we set the first one to the second, and then that's how you avoid. That's how you avoid repetition. So we're gonna try to write it ourselves. Man, I can't believe I failed this one. This is a easy one. It's not hard. Right, so we need how is this helper? So for each star, we have to go through the entire thing, right? It's just at the very beginning, we're gonna set the first one, right? We're gonna set the first one, and then we go for the remainder. We have to go through every single one of them. How do you cache the target? The target is a cache because we doing target on the entire nums, right? So we can just say current target, and this one gonna return an int, like how many combinations we have with the current target on the entire nums, right? And then this one basically just saying we're gonna say if current target is 0, return 1, right? And then I'm gonna say for in nums, actually I don't even need to, just for n in nums, right? And then for each one, we're just going to say res plus equal to helper current target minus n. And if n is smaller equal to target. All right, I'm going to do this. And then res is 0 to begin with. And return res. I'm going to put a cache on this. RRU cache. Max size equals none. All right. And then what do? We simply do res equals 0, right? And then we say we do helper. No, we can just return helper target. Okay, let's try this solution. That's 2. So solution 2. Max recursion. Max recursion. Okay, it's still not right, huh? It's current target. Right? If target is 0, yeah, what's the problem? If target is 0, return 1. If target is not 0, and then which target is 8. So we're gonna do, yeah, let's try this one first. Make sure this one, yeah, this one's also current target is 8, right? So for n is 1, right? N stuff from 1 smaller than, oh, current target. There we go. Yes, there we go. Ah, what had this as a fail. Wasn't able to solve this one by myself. Had to refer to the solution here. I think it's just why did I get stuck? Let's pass it first and then kind of think back on why did we get stuck. Like, why did we get stuck? Yeah. I don't know why we got stuck. What's the runtime? I don't even know what the runtime is. Whatever the runtime is. All right, I need to think about why did we get stuck? So why did we get stuck initially? Well, we got stuck because we were stuck on how to actually do permutation with no repeats, right? This is what we stuck with. We stuck with how to do permutation with no repeats. But in fact, we don't have to do that because we had the idea that we're gonna specify one value, right? We're gonna fix one value and do everything else. We said we're gonna fix the first position of 1, we're gonna do everything else. And now we say we're gonna have 2 1s, 3 1s. So we kind of, yeah, we're breaking it. We're breaking it. In fact, we don't have to do that because if we fix the first position as a different value, we don't have to worry about repetition at all. Repetition at all. Yeah, if we fix the first as a different value, the first one is different, and then we don't have to worry about repetition at all. So basically, we're saying let the first position be 1. Given the problem 1 to 3, sum up to 4, we say let the first position be 1. Then we want to find all possible combinations that allows 2, 3 to come up to 3. Then we fix the first position to be 2. No, 1, 2, 3. That's the trick, right? 1, 2, 3. I fix the first position to be 2. Then we want to find all possible combinations. Actually, it's not permutation, it's a permutation. Permutations. Unique permutations, right? Unique permutations. It allows this. I'm going to find the first position. We'll mark all possible, all possible unique permutations that allows 1, 2, 3 to add up to 2. And we don't have to worry about repeats between these two operations because the first one always starts with 1 while the second one 2. Hence the memoization recursion solution. I think we got stuck. I mean, we got very close because this one we did say we want to fix, right? This one we fix 1, and then we trying to we go through everything. This is actually very close. We fix 1, then we say current minus this, right? That's the same thing, current minus this. And then we're trying to, it's just we are like appending, and we don't have to append. We just need to know the, like this, it should be just like +1. And we are trying to find like all of them, right? We're trying to find all possible solutions. But in fact, we don't have to. Yeah, we're getting very close. The original idea is very close. If you look at it, if it is 0, we do something. Otherwise, we do something else. Otherwise, it's something else. And then we have, it's the same 4. And then we simply got wrong because we're trying to fit. So the idea is correct. My original idea is correct. Just it was wrong in the implementation. Yeah, we shouldn't try to fit the list because it's not necessary. Can we find a bottom-up solution? Well, a bottom-up solution means what is a bottom-up solution? A bottom-up solution means we have 1, 2, 3. We want to get a 4, right? Bottom-up solution just means if I want 1, we need to find 1, 2, 3. Get so we need to find a number. We need to find 1, like 1, 2, 3. Get to 1. And how many is that? And then 1, 2, 3. Get to 2. If one do 1, 2, 3. Get to 2, that means we have to do 1, 2, 3. Get to 1. Right, that's a +1, and then 1, 2, 3. Yeah, 1, 2, 3 +1 to 1, and then we need to sum up to 3. That will be 1 plus 2, right? So maybe that will be 1 plus 1, 2, 3 to 2, 2 plus 1, 2, 3 to 1, 3 plus 1, 2, 3 to 0. And 1, 2, 3 to 0 is always a 1. I think it's possible to write a bottom up. Let's do this as a little bit salvation. Okay, so it's bottom up dp. So we're gonna have a dp equal to 0 times 1000 on 1, and dp 0 gonna be 1, right? And then what I'm gonna do is gonna be for I in t in range 1 to target +1. Okay. And then what we want to do is, what do we want to do? So we want to calculate how many is 1, right? So we're going to say for each one of them, right? For n in nums, right? For n in nums, we're going to say if t as target minus n is larger than equal to 0, right? If it's larger than equal to 0, then res plus equal to dp t minus n, right? And in this one, shouldn't we sort the original? Not necessarily. So no, we don't have to. So t minus n, all right? So we have for n, and then we just need to know the remaining, right? The remaining, if it can be calculated. Yes, actually it's not res, it's going to be dp what? dpt, right? So dpt is going to be t minus n. And I'm going to do this, and we're going to return dp target. Let's try 3. Yes. I have a better understanding now of this, right? And this is actually target plus 1. Then with bottom up, you can see the runtime. Right, bottom up, the runtime is going to be O target OT TN, where T equals target and N equals random. Yeah, this is the same thing. It's not hard when you look at it right now. Yeah, it's so simple, huh? It is simple. It is not difficult. It is not difficult. It's a medium question. It's not difficult. I just wasn't able, like, I got stuck here, and then I get out. The next model I was thinking is wrong. I was trying to think, okay, I want to put 1, 1, then 2 ones, then 3 ones, then 4 ones. And then when I think about that, then I have a combination problem. Because I want to do all the ones, and then as I do recursion, I don't want to involve ones, right? And then I want to get the result to do the permutation myself. But apparently that's not working. That's not gonna work. I should just take, it's not taking, just like set the first one as a 1, right? And then the remaining we should take all of them, right? All of them you can just randomly pick. And because the first one is 1, that would be definitely different when I set the first one as 2. So I was just, wasn't able to come up with that. All right, anyway, it's a long time today, and we failed. I mean, it's okay, right? It's okay. Failure is always part of the learning process. Let's hope that, I mean, this is a basic DP, right? So let's just hope if we ever encounter something similar, we will be able to get a better outcome. All right, that'll be it. I'll see you guys tomorrow. Adios.